Physics, part 188. Monochromatic light. We've got an example for you. Monochromatic light is incident normally on grating with 7.00 into 10 power raised to 5 lines per meter. A second order maximum is observed at an angle of diffraction 40.0 degree. Calculate the wavelength of the incident light. The slits on the diffraction grating are created by drawing parallel lines on the surface of the plate. The relationship between the slit spacing d and the number n of the lines per meter is d is equal to 1 Newton. For this grating, the answer is 460 nanometer. Now it's your turn. Number 1. Monochromatic light is incident normally on grating with 5.00 into 10 power raised to 5 lines per meter. A third order maximum is observed at an angle of diffraction 78.0 degree. Calculate the wavelength of the incident light. Number 2. Light of the wavelength is 5.90 into 10 power raised to -7 meter is incident normally on a diffraction grating with 8.00 at 10 power raised to 5 lines per meter. Calculate the diffraction angle of the first and second order diffraction images. Number 3. Light of the wavelength of 590 nanometer is incident normally on grating with spacing 1.67 into 10 power raised to -6 m. How many order of diffraction maxima can be obtained? The diffraction grating with white light. If the white light is incident on a diffraction grating, each wavelength delta making up the white light is diffracted by a different amount as described by the equation, and lambda d sine theta, red light because it has the longest wavelength in the visible spectrum, is diffracted through the largest angle. Blue light has the shortest wavelength and is diffracted at least. Thus the white light is split into its component colors, producing continuous spectrum. The spectrum is repeated in different orders of the diffraction patterns. Depending on the grating spacing, there may be some overlapping of the different order. For example, the red component of the first order image may overlap the blue end of the second order spectrum. An important use of the diffraction grating is the spectrometer. Is the spectrometer a piece of apparatus used to investigate the spectra? By measuring the angle at which a particular diffracted image appears, the wavelength of the light producing that image may be determined. We've got the section summary here. The diffraction is the spreading out of the waves after passing through an aperture or meeting an obstacle. It is most obvious when the size of the aperture and the wavelengths of the wave are approximately the same. Single slit diffraction in the condition of the minima is at a sine theta is equal to n lambda, where a is the width of the slit. The condition for a diffraction maximum in diffraction grating pattern is d sine theta is equal to n lambda, where d is the grating spacing, 0 is the angle at which the diffraction maximum is observed, n is the integer, the order of the image, and lambda is the wavelength of the light. Section questions. Number 1. Blue and red light with wavelengths of 450 nanometer and 650 nanometer respectively is incident normally on diffraction grating, which has 4.0 into 10 power raised to 5 lines per meter. Calculate the grating spacing. Calculate the angle between the second order maxima for these wavelengths. Calculate for each wavelength, find the maximum order that can be observed. Number 2. Discuss any difference between the interference patterns formed by A. Two parallel slits 1 meter apart, diffraction grating with the grating spacing when illuminated by the monochromatic light. Length of the wavelength 633 nanometer faces through the slit calculate the angular separation between the central maximum and the first minimum.